Now let's see the advantages of solid modeling with Autodesk Inventor. When you are designing with Autodesk Inventor, you get these advantages. Number one is great visualization. Then your modeling is parametric. I will explain that soon. There is automatic updating of drawings. It's automatic and you can update your drawings. So that should be automatic updating of drawings. Then, permit me, automatic updating of drawings. Okay, then we have rapid prototyping. I will explain that as we continue. Then we have 3D analysis of your design, of your machine. In Autodesk Inventor, you can do animation and simulation. Now, before I continue, you need to understand that Autodesk Inventor is a type of 3D CAD, computer-aided design. There are other 3D CAD. AutoCAD is an example itself. 3D Max, Maya, Pro Engineer, SolidWorks, they are all types of 3D CAD. So please take note of that. So when they mention AutoCAD, it's a type of CAD. Inventor is also a type of CAD, but they are 3D CAD. We have 2D CAD like AutoSketch and so on. Now back to advantages of solid modeling with Autodesk Inventor. Number one is great visualization. You can visualize the machine before you begin to manufacture or fabricate it. So that will reduce our risk. It's good for risk reduction. Then your team can easily communicate the concepts and they can sell their ideas. They can see how the machine looks like and they can be convinced that the machine will work. You look at the diagrams here. They look as if they are real thing, but I want to tell you they are digital prototype, they are digital drawings. They are yet to be manufactured. So these are just the drawing, but merely looking at this, the engineering team or the production team, they can quickly see how the machine look like and they can communicate and sell their ideas. So these are the things you'll be producing. These are the drawings you'll be making with this software. Then in Autodesk Inventor solid modeling, the model is parametric. Now in AutoCAD, you define distances by setting initial input. And to change the distance, you may have to delete and type the distance again. For example, you draw a line. You have to give the length of the line in AutoCAD. But in Inventor, you can draw a line without giving it a length or dimension. You can come back and change the dimension. The line will adjust automatically. That doesn't happen in AutoCAD. So that's what we call parametric modeling. If you change the length of the line and along X direction, it affects it in the Y direction. It's parametric. So a changeable parameter defines the position and length of each point. Probably you draw a line, you draw two lines at angle 90. If you change the angle to angle 80, the line will adjust automatically. That's parametric. That is based on parameter that you supply. So the parts, you do not have to be redrawn when a design variable is changed late in the design process. In AutoCAD, if you make your drawing in AutoCAD, you transform the drawing, you transform your sketch into 3D, you extrude, and it becomes a solid. Now, later when you want to change the length, it may not be possible, you have to redraw it in AutoCAD. But in Inventor, that doesn't happen. Just change the length, your 3D model will change, the orthographic, the section, whatever you have extracted from the drawing, they continue to adjust themselves. That is what happens in Inventor. Now, you may not understand this in theory, but I want you to take note of that. When we begin to draw practically, you will appreciate what I'm saying. Then, automatic updating of models make it easy to create and compare several different configurations. You can make a model You can duplicate it. You can Control C and make several copies. You can be changing some things in each of those copies to see how the machine will behave. And so that automatic updating allows you to compare different configurations of your models. That's a serious advantage in Autodesk Inventor. Like I said, we have automatic updating of drawings. Any changes made to the 3D model automatically are updated in the projection. Look at this drawing, for example. We have a 3D model here. We have the front view here. We have the side view. Then we have the plan. This is the plan view. This is the front. This is side. This is the front. This is the side. And this is the plan. If you are an engineer or a structural engineer or a mechanical engineer or a Greek or civil, whatever engineer you are, you must have passed through drawing. You understand what I'm saying here. This is a 3D projection where the front view is below, the plan is on top, and the side view is there. Now, if you happen to change the length, any length here, this model will adjust automatically. So the length will adjust themselves. All the views will be updated automatically. If you change the length in the front view, it is going to update in the side and the plan view. So that is the advantage of 3D modeling with Autodesk Inventor. Now let's look at another advantage, number 4. That is 3D rapid prototyping. After you have created your 3D CAD file, you can send it through email to the company that want to produce it. They can quickly create a 3D rapid prototype. They can create a prototype. Prototype is a small version of your final machine. So they can create a small part of it, a small model, a small version of the machine, and send it back and try to see how the machine will look like. So the designer will check it and see whether it satisfies his requirements. So that's what we call rapid prototyping. You create a prototype. You design a tractor. The rapid prototyping facility can use plastic to create a small version of that tractor to see how it's going to look like. The designer will check it. Your team can check it. If they are satisfied, they can go ahead to the plant and begin to produce the real tractor. So that is the advantage of solid modeling. Then another advantage is 3D analysis. Now look at this. You can see that simulation is showing how the part is moving up and down there, and that's what we call simulation. Then on the right hand side here, you can see finite element analysis. So we use FEA in Autodesk Inventor to see the area where stress is concentrated. We call it stress analysis. Before you begin to manufacture your machine, you can know the area of stress concentration where the machine will likely fail if there is too much load on it. So these are the things we do in Autodesk Inventor, which I'm going to explain in this training. You can see that you are going to have value for your money in this training, and what I'm going to impart to you is more than the money you pay. I assure you of that. Then we have animation. We have animation and simulation. Machines can be digitally animated to show motion. Look at this, for example. You can see the breakers. This machine, I primarily designed it for cassava sieving. So that part, the front, all these rod here, they will break the cassava clod, the cassava mash, and this part will convert it out of the machine. So you can see the animation to show how the part is working. And on the left hand side, it shows how the machine is assembled. So that is the animation there, how the machine is assembled. You can see the bed guard, you can see the electric motor coming into position, you can see the part, and so on and like that. So these are the things you do in Autodesk Inventor, and I want to assure you we are going to do that. Now